Yes, good evening. Um, Welcome to the 11th week of the session, like for the course of a statistic for biomedical engineer. I am MD Ashutraja, PMRF fellow at Naritrichapalli, and that will be on the last stage of the topic that we are seeing. That my screen is visible. Can you please just confirm me?
There is visible.
Yeah. Well, if you have any doubt, so please ask. Otherwise, I'll just give the brief also. There's no issue. Hopefully, till the last session, there will be no doubt, or the last week session, 10th week. So today we are discussing based upon the 11th week. So I'll just give the brief, like how it's useful and then how it's going to be like we are at the end, statistic part. Then from here we can take transformation into the machine learning part and then other parts and all. So as the course itself is a biostatistic, that is statistic for biomedical engineer. So this course is actually meant to for that biomedical engineers. But this course can be used for any statistician they want to take check for the any efficacy and all. Because that we have seen in the general cases also. Like we started from the basic, then we deep dive into with multiple variables and all that we have seen already. So if you see in the still first and second week is it was just a introductory part, and we have seen what is the need of a statistic and all. Because whenever I'm saying if any of the diseases are there, for that they have made some sort of drug, so whether that drug passed the regulatory check and all or not, because or that drug is having like a significant the population was having significant population was taken for the study or not. So that should be done with the help of a statistic itself, because that the drug itself will check for the efficacy and how much effectiveness is there. So we are not going much into the what we can say biology. We are not dealing about the pharmaceutical companies and all, what is the composition and all. But we'll check what will happen if we change that much content of the pharmaceutical or drug. Let's say I'm changing the some content of the titanium and all in the some sort of that hip implant, that material we are making. So we have to check with, okay, if that percentage change came, so whether that our that the material we are making for the bone it's okay or not, or that like after the testing and all. So that's what that we have to check with the like statistic and all. So that's what we need. So first we have to start with the, let's say we have any data in all others, so we have to start with the like a description, whether the what is the data set size, and what is the mean, what is the mode, what is the what we can say deviations and all that we have. So based upon that we will check with the, okay, we'll go with the probability theory, and then we have checked with the different types of probability expected outcome we have seen the conditional probability, we have seen the different types of the event, we have seen like independent event, then the that is exclusive event that we have seen and all. Then we checked with the distributions also. Distributions called Poisson's normal, then binomial distributions and all. And if we are like in our cases, that most of the cases will be having the normal distribution we are going to take into the consideration. Not but we have to assume like the data following the normal distribution, so that it will be like a smooth curve will be there. Like it's not the normal exactly, but it should follow like mu will be zero here, and then standard deviations will be there. Then, if you check, like if you have some that the delay time or manufacturing time that will come, or time waiting time, so that comes under the exponential distributions and all. Then we have checked with the variances. Variances because earlier till we have discussed the barrier description, like what is the mean, mode, and median. So we have to check with the how much variability is there from the mean, because if the variability is more means error is more, so it means data is not having consistent, so we'll not get whatever the desired result we want. Okay, so just good. So whatever the results that we need, that we'll not able to get it, so that's why we have to keep check on the variability also. Error should be less, for any of the testing that we are going to do, that should be error should be less and all. Then we came across the what is the inferential statistic. Like we have checked with the descriptive statistic. Descriptive is something that will talk about the numbers. Descriptive or descriptive will talk about something called number. And if you go into the inferential, like we are going to make some sort of conclusion based upon the data that is given or based upon the number that we have given out. So we are going to make some inference whether whether the effectiveness is having changes are there, but that is the before and after. Let's say I'm going to give some training for let's say that like a physiotherapist is there. Physiotherapist is there, so they're going to they'll be designing some sort of exercise for that, what you can say, after the surgery or after the like any of the muscles that what you can say treatment and all. So they'll check, okay, before the exercise and then after the exercise there is much change came or not. Like they'll check with the efficacy of that, or either the drug delivery what happened, or maybe the machines having that. So we'll make a conclusion, or how much difference is coming before and after, that will talk number. So that we'll able to say with the inference something that we're going to make some conclusion. Will not talk only the numbers, but will make the decision or will calculation and all. So for that we'll start with the central limit theorem. Central limit theorem is a universal problem that we can solve for the large data set, or even for the smaller data set also we can work on it. So in that, like it's a z is equal to x minus mu by n, sigma. So it will go like this, and so that we will deal about that, and then we can check with the n is equal to 10 to that 100 also. And if the number of the sample size is more, so it will go more toward the normal distributions. And here we don't have the conditions that that data should be normal distributions. It will be like IID. IID is something called like it should be independent data should be there between the populations or between the groups and all. Then we have the confidence interval. Let's say I'm saying, okay, this much changes is there, this much probability is coming. So what is the confidence interval? Like what is the range of that that we can say and all? Like what is the probability? Well, so that we can check based upon the confidence that is the confidence interval. Then we came across the hypothesis testing. So in hypothesis testing is something that we are going to make some hypothesis or that our objective. Let's say that I have the fertilizer for any of the crops or the field. I will take one, two, three, four. That is the fertilizer will be there. We'll say for the soil type one, this fertilizer I kept. For soil type two, we kept this fertilizer and all. So we'll check. Okay, we'll keep the hypothesis. Okay, I kept one first fertilizer in the first soil. That much change will come, or there is much difference will come, or we'll keep that fertilizer in the second one further, so there will that difference will come. So we're going to make some hypothesis or objective of the study, and then we'll work around of that hypothesis itself. So if we talk about the what are the element of the hypothesis, it's start with the null. Then we have the alternative. And that null hypothesis is something we'll call a status quo. Status quo is something we are going to make the like it's a basic fundamental. Let's say I'm going to fertilizer with three different fertilizer is there, and that we will use it. So we'll say, okay, there is no difference will come where we'll keep all three different, that is the fertilizer for the same soil. So it will, the difference will be not there. So it's a status quo. And whatever is the alternative? Alternative is something that we are going to say, okay, like either there is a difference will be there. Either we'll say first fertilizer having that greater than the second one, or second one is having the greater than the third one. So in that is the case will be there. So in that will be having first tail, two tail, or the one tail. If you say two tails, something will say mu1 is not going to be mu2. In the one tail, either left or right tail test will be there. So in that again also, if you go with the large sample test, so we can go for the large sample test also. So that will work on the central limit theorem and all. What is the p-value? P-value is something called probability. Is it? So probability of rejecting the like our hypothesis and all. Then we have discussed about the small sample. Then we came across the student t-test when the number of sample will be the in that will number that will be with the less than 30. So we have the independence like t-test will be there. T-test, in that also we can check for the two independent or dependent like pair t-test, independent p-test and all we can check it out. What is type 1 error? Then we have the type 2 error will be there. Let's say we have the contingency table is there, actual, and this is the predicted. Yes, no, yes, no. So this will be the one, then again one, then again came. So if you're not able to make, so this will become your type 1 error and this will become your type 2 error. Is it clear? Like in this, that is, there's no doubt now. We'll start like yeah, that we will start slowly. We'll go. I'm just giving the brief so that that you can have the idea. Like because a similar question will be going to ask in the your final exam also. Then we talk about the power of the test. Power of the test, something we are going to tell, okay, that much 80% of the, I am saying 80% of the confidence, like that the sample size will be this much, or that the inference is correct. Then we came across the chi-square distributions, where we came chi-square distribution when we talk about differences like the variations and all, or maybe the goodness of the fit will be there. Something that will come. Then hypothesis to test using the variance. Like till now we were discussing based upon the mean or change in the mean or difference in the mean and all. Now we came across because that the mean will not give clear picture in the variations. So we have, so that we have to move to the variances. So in that f will be something called like f test like higher variance upon lower variance. If that f value is going to be high, so we'll say that the higher significance results we have. Then we came across the test of independence like that based upon the chi-square distributions only. Then we check with the probability plot or QQ plot. If the number of sample is going to be like 100 or more, it will become the more of a straight line. A straight line like it's a uh, linear QQ plot will be there. Then we check about the F distributions also, and we have then introduced like that all the tests we have seen. This is going to be for the use of the only two variable. If the number of variable go or the number of group will go more than two, what will happen? So we'll not able to do. If we do, so that type one error is going to inflate. Inflate means it's going to increase. So to counter that what you can say disadvantage of the test, that let's say we have that only two groups, so we can go with the t test. There is no so there is no issue. Either we can go with the f test, either we can go with the chi-square test and all. It's based upon the what or where that we have to use it out and all. Okay, once that our group is going to be beyond of the two. So if we are going to, let's say I have one group, two group, three group, but the test if you go one, two, two, three, then one, three. So we are going to take individual two groups. So there is chances of the error one, type one error will increase. So to counter with that, we came across the ANOVA. In that, they're going to more on discuss on the what you can say mean squared error. It's something like we're going to calculate the mean square error. So in that, like we are having first one, we'll be having one way ANOVA, then two way ANOVA will be there. So in then after we came across the like joint distributions, like we'll be having x, y, or the variances, covariances will be there. So that's called that. Then we have introduced the correlation. What is the correlation between the one variable to the second variables and all. Then we have discussed the simple linear regression, like fit of the line. We have fit y is equal to mx, or we have checked about the y mx plus c. We have checked with that, then we calculate the r square statistic also. Like what is the correlation coefficient is also we have checked it out. Then we have checked with the multiple linear regression also, and then for the multiple linear that the regression we have the adjusted r square statistic and all. Then we were having a simple the linear regression, like we can't go ahead with the all the time. There is because it's linear, so the error chances will be the more as compared to the like we having the functions always will be the uh, non-linear. So for that we came across with the logistic regression or no logic function. Logic function is a similar thing, only it's deal with the log of the functions is there. So, and if we talk about the simple linear regression, it's actually for the continuous variable. And if we talk about the LR, it's a logistic regression, it's a for the binary classifications and all. So we have to see the differences like where we're going to use that the simple linear regression or where we have to use the something called logistic regression. Whenever we have to make some classification, let's say I'm going to let's say one example like that the mail came either it's a spam or not, either yes or no. So it will come under the classification, either it will be 1, either it will be 0. So in that case we have to use the logistic regression. So in that will be coming the logic function. Then we have the that's the log likelihood function. Likelihood function is something called probability of that thing will happen. So then we have model the ANOVA using the LR. LR means that's called linear regression. That we have checked it out because we have made the group. We were having two groups over there, X, Y, and then C are there. So we'll say X that is going to be 0 when it's come with the second function, Y is equal to 1, then it's going to be like C function. So that we have made the group and all that we have done the grouping and all, we have to check it out. Then we have done the problem. Then one way, another we have also checked with that. So after that, we came across like okay, we need two more than the variable, or sometimes there is interaction between the group that the variable will be there. So now before that, we have to introduce the design of the experiment. Let's say we have done all this thing. We have let's say the data was there, but now when the problem became more and more complicated, so it's very important to design the experiment in a proper way. If we don't design proper way, there is chances that we are going to do the that uncontrollable factor will come into the picture like anything. So that we can control, it will affect the our study or it will give the whatever the results we want because that factor will go into the um, major factor and all. So that we have to avoid it. So first concept in the design of experiment is something that design of experiment is idea is we'll be having the input, we have the black box. One will be the controllable factor that we know. Second will be the uncontrollable factor that we can't control. Then we exhibit that having the output. From this output, we are going to make the some sort of statistical testing and all. So in this, we have the first design is the blocking. Then RCPD. Then we have the LSD. Then we have the GLSD. Then it will come. So in the blocking CRD, we are not going to do the blocking directly. It will go into and then like it's just there is a single that the Nugent's factor. Nugent's factor, if you know, like something called unnecessary or uncontrollable factor. In the randomized complete block design, let's say I want to check with the fertilizer testing and all. So we are not much bother on the soil. So that soil will be the our uncontrollable or the Nugent's factor. So that will comes under the RCPD. Then we have the Latin square design. In the Latin square design, what we are doing, we are going to take two factor, one row, then column. Is it? Then we have the Gracio Latin square design. In this, that the one Greek letter will comes into the picture. Like with the each factor, one the Greek that the letter will come into the picture. One row, one column, and then the one Greek letter. So three original factor we can control over it. So that is something that we can do till three control. Three factors that we can control. So now then came across the now we have to go no because the things that we are discussing all individually, we are not discussing like something that interactions and all. And there is obvious chance whenever we will be having any experiments and all, there is a chance will be there, we'll be having the interactions. Like one factor will going to cause or it will depend on the another simultaneous factor. Like it will be simultaneously. Means the both will going to change in a like a similar way. Or either the if we change to the one, second will also change. So in that case, the interaction will be there, AB. So in that we have the factorial design. Factorial design that we're going to divide into the two level, two factor, or something then 2 to the power 2 factor. So that people are doing with the what you can say p to the power k. T to the power k is something called P will be the level, K will be the factor. So that we can do, let's say if we have the two level and two factors, so 2 to the power 2, it will come 4. That four times of the experiment we have to do it and all. Then that will check on the discussion on the interaction. Then we'll introduce the two-way ANOVA and we'll discuss two to the power 3 factorial design. Like when we'll have let's say we have what we can say two factor A and B. So one will be the that will main effect and B will be the main effect and AB will be something that will call interaction effect. So first we'll see what is the actually interaction effect. Can you tell what is the interaction effect? This I think I have seen or we have discussed in the last class also, last session also. Is it? So interaction when we'll say when the effect of one factor, it's actually depends upon the level of another factor also. It's something like we're having y is equal to earlier it was mu plus alpha plus beta plus eij k, whatever it was there. But now another factor will come that alpha plus beta will be having another impact will be there. So in other, the combined effect two factor is not additive, they influence each other. It's not directly additive, but it will be the influencing like it's not the something called independent. Like when the case of independent, that will become the zero. That we have seen in the that we have seen in the case of uh, probability and all that we have seen. So let's say if you're doing the testing, so factor A will be the types of the fertilizer. So that will comes like the main effect. Then factor B, we have irrigation level. Then main factor. Then we'll check factor A and B together. Like we'll check if the chemical fertilizer perform better under high irrigation. If organic will perform better with the high or organic will perform better with the low. So it's something it's going to be like interaction is there. It's influencing one to the second. So, but not under low irrigation, then there is an interaction between the fertilizer type and irrigation level. So, when we talk about the interaction effect, so it will go y I j k mu, it's overall mean, alpha plus beta, it's I j plus alpha beta I j plus error. Come. So this factor we call interaction factor. It will not the zero. In the case of there is no interaction, it will become the 0 or zero point 0.5. So that we can uh, neglect it. This factor called interaction effect. So that is the funda that we have for the two-way ANOVA foundation. We can say. Okay, so if you see some sort of example that we have the agriculture fertilizer with the irrigation or crop variety with the soil type. Let's say fertilizer having A, B, C, that the irrigation that's called the low, medium, and high. So what will happen? If fertilizer will take A, then irrigation is having low, so that the yield will be less. So it's the interaction. Again, and that the fertilizer A, but with the high irrigation, it became more. So it's the interaction is there. Similar way, machine type plus operator skill. It's directly proportional. If that operator is having a highly skilled, we can get the better output for the machines and all. So it's that the similar way, temperature and pressure in the chemical yield. We want more like fast chemical things to be changed. We can change the temperature and pressure. It will become yield will be the more but the properties will vary how we are changing. So it's something that will vary that our outcome will going to depend upon the both factor, not single or alone factor. Similar way, we have for the case of medicine that's called drug and doses. Okay, so if that drug and doses, if we have that, let's say paracetamol 650, so we'll give one in a day for the adult. If the same paracetamol having 400 or maybe 350 or 200 to 250 and all, we'll give two doses, we'll give per day and all for the adult and all. So similar way, it's something based upon the doses, the drug will also change or the drug intensity or drug capacity, the dosage will also change. Similar way, treatment and age group. If we have the minor or the kid are there, their treatment will be different. If the same way that if we having the old or the senior that is citizen, their treatment will be different. For the young, that will be again different. So it's something like it's all independent. Like no, sorry, not independent. It's a dependent. It's something the interaction is there. One will influence the other. So that's why we have to every time, whenever we are going for the testing and all, we have the multiple groups are there. We have to always take care of the interactions also. If we don't take the interaction, what will happen? We will be able to end up with the some sort of error, and that will going to affect our interpretation, or it will not give the better result or better output and all. Okay, then we have the education. In this also, teaching method accordingly will change with the student background. Let's say I will not go much into the deeper, like if that is like if you see in the case of some big coaching of the IIT and JEE, so they will be going having different batches will be there based upon that paper that students will be having. Let's say they have done for the 2 year drop, 3 year drop, they'll keep one group, or maybe the high that IQ level, their solving capacity is much better, so they will keep in one group and all. So similarly, like the teaching method will also change. So it's some sort of truth of fact. It's going to always interaction will be there. Okay. So so that is the same thing that I have explained here also. Let's say that machine speed and the material type. If we have factor A, that's the machine speed slow and fast. Factor B is the material type, plastic and metal. In that case, fast is speed, increase defect for the plastic but not for the metal. That we already know, because for cutting for the metal we need the like that tool should be at high speed, but for same plastic that we can do slowly, if we do at the faster speed, the chances of defect or that the heating will be more, then the chances of defect will be more. So it's again it's a changing with aspect of what we can say that one factor with the second factor. So similar way, but we have in the case of let's say that the effect that the factor A teaching method, that will be the one is the lecture, second one is the and that is interactive. A student background, that the urban and that the rural. Interactive method boost score for the urban student, but lecture method work for the better. That's called rural student. That some study will be there. It's again that can be the case of the reverse also. So we are not like too much rigid about what they told. Similar way for the temperature and the humidity, and also that we have to check it out. Okay, so now we know that how the interaction among the variable is happening. I think it's here, till here it's clear, na?
Yes, sir.
So now we'll introduce the two-way ANOVA, is it? Or we'll start with the two-way ANOVA. So two-way ANOVA, if you see for the case of like examine the variability in the data, when we'll be having is like some two factors simultaneously or three factors simultaneously that we can do with the two-way ANOVA. In the one-way ANOVA, compare mean across the group defined by a single factor. Here the factor will be same, like only one. That means that the level will be one, but the fact like the things will change. Let's say for the effect of different fertilizer on the crop yield, but we are not much thinking about the soil. If we'll take soil in that into the consideration also, so it's some that become the simultaneously. So it will come under the that the two factors simultaneously. So that we call two-way ANOVA. If you take soil and fertilizer with the irrigation, then we have the three factor. Three factor. It means that will go under the case of three-way ANOVA. So where we will able to use it whenever we'll be having two factor, it will come under the simultaneously. But there in the case of fertilizer, A, B, C, D, E, F will be there. In the case of like single factor, we have single factor is there. Let's say that fertilizer is there. Fertilizer type will be the T1, like F1, F2, F3, F4. So there we can use the what we can say one way ANOVA. Let's say I'm saying fertilizer 1, 2, 3. Then simultaneously I'm saying soil 1, soil 2, soil 3. Okay, so in that case, we have the two factor, but dealing with the different aspect also. So that will become the two-way factor, like a two-way ANOVA. If you're going with the fertilizer, like fertilizer 1, 2, 3. or soil type 1 to 3. Then the irrigation method, like that's called low and high. So that will comes under the three wave ANOVA. So it's going to one way ANOVA. It's going to compare across the group defined by a single factor. But two wave ANOVA is actually a two factor. It means and it's with the called more than two level. So first will be the goal. Test the main effect of A that we used to check with the case of RCBD and all. Let's say when we have the RCBD that will check one factor. Either way, we'll take in the case of that one. Then the individually factor B also. Then we check with the interaction effect also. So that is a very important part and all. So it means like fertilizer A and irrigation B on the crop yield. So I think the two-way ANOVA is clear. So two-way ANOVA is actually for the two or more category explanatory variable, and assumption will be the same as it is what we have taken for the one-way ANOVA. It should be the uh, normality, then equal variances, then independent error should be there. Like the variance should be equal in the all cases and the quiz and all. So factor will be the an independent categorical variable. Factor will be like let's say either the fertilizer. When we talk two-way ANOVA, we'll be having factor and then label, then the main effect, then interaction effect. Factor will be the an independent categorical variable like fertilizer type or maybe soil or the irrigation and all. Okay, or maybe some other factor will be there that will be able to check it out. Then the label will be the fertilizer will be the type 1, type A, type 2, B, C. Soil, soil case 1, soil case 2, soil case 3. It's label. Then that is the irrigation that's called the low, medium, and high. So that's called label. Then the called main effect that the independent influence of the one factor on the dependent variable. Let's say factor of A, factor of B. Let's say I have two factor, two variable. So it will become A, B, A, B. If it is 2 to the power 3, it will become 8. A, B, C, A, B, B, C, C, A, A, B, C. So that this is the called main factor. This is called main factor, interaction, and interaction will be there. So that's how it will be the interaction effect will be there. So till now we were discussing about the individual effect only A, B, C, either in terms of row, either in terms of column and all. Okay. So now what is the assumption that we'll see in the detail? First one is the independence. That we are discussing from the starting of the our statistic portion, is it?
Yes, sir.
Then second one we have that normality means that the error should be normally distributed and then that we can check through the QQ plot or Shapiro-Wilk test. If time permit in the last class that we'll see how to check with the normality with the Shapiro-Wilk test. Then we have the homogeneity of the variance. Variances should be equal all across the group. We should not have different variances should be there. So and tested using that's called Bartlett test on that level test. That will I will try to introduce in that if you take overall one session that is that somewhere I think fill the form of 14. I don't remember exactly, but that mail that you will get just check the mail like in the second week, not like this week. Today is the 11th lecture. Then that one more lecture will be there on Saturday. After in that week only we'll be having another lecture. I'll just see that which date I kept. I forgot actually. I think kept on 14 or 15. Either date I kept. So that will check it out. Then we have that additivity, no interaction model and all. Like it was something that was there, but here interaction will be the included always because when we talk about the two-way ANOVA, if there is no interaction, it will become the ideal case. Means AB is equal to 0, or maybe that a coefficient will be the 1. That will check what is that actually AB and all will check it out. Then if you see if you check like more into that, sometimes that researcher might want to simultaneously examine the effect of two treatments where both treatments have nominal level of measurements. Like if any factor or variable that have very significant effect in the study, so that will check it out. Let's say that effect of the sex, and like that's the male and female on the wages. Wages means salary and all, that we can check it out, because that both are having that very significant, that is a significant number, and somewhere some company having and some sort of changes will be there, somewhere that the female will be having higher, or maybe the male is having higher, or somewhere same is there. So that we can check it out, like it depends upon the industry where it's going, that we can check it out. Or effect of the level of the that the pollutions, or level of the city services on the housing prices. Let's say if tier 1 city, we have Hyderabad, Mumbai, Bangalore, and Chennai is there. So these are that what was it, tier one city and all. So based upon there, the pollution will be also one factor, like tires, city tire, and then the housing prices will be the another factor. So now we have to check with the all together, because simply we can't take independently. If we take, no, I want one house, and I have the budget this much 4 crore, and I want to anywhere to go. But what will happen? If the city is having a tier one city, will get the less, the what you can say, that not the small house will get it out, or will not get that large house. If we go, if we going to move into the tier two or tier three city, so it's something will that will be having, like will get very good what is the pricing of the houses, even that the pollution will be the less, and that all factor will comes into the picture. Then effect on the of the region or religion will be there on the income also. So it depends upon the, if we have the um, Middle East, then we are having West, then we have the Asia. So it will be change. Here that we have the oil is there. Here we have a tech is there. Here we have that what you can say, that assembly and all will be there. So it's a change. It will change with the regions and all. Then either we can check with the there is a difference of the because of the sex alone, or maybe the race alone. So we'll check, or maybe we that we have to check with the combination, like interaction, that we have to check it out. Okay. Sometimes that we are going to check. Okay, we were having where here. Uwe ANOVA, that will check with the balance design with the classical experiment. Like we'll be having 2 into 2, and in A, B, here also A, B. Let's say we are having one is having here crop, or here having we fertilizer. So in that way also, in each cases, that number of sample will be the, or number of experiment will be same. Like it's something that will be having the balanced design, will not having the any irregularity, or maybe the data imbalance should be not there. Is it? So data imbalance should be not there. So in that, like we can see the ANOVA is going to complicate the problem. Whenever we'll be having two or three, four more variables will be there, so that will go with that methods only. So in the case of that psychology classes, we might spend a lot more time going to the ANOVA. That is going to something that going to more used. And in the starting itself, we have to check with the balance design. Means all cell frequencies should be equals. That let's say for the example, five white males, that five black males, five white females, five black females. It means in all each cases we have the equal number of frequencies are there. So that will that the balance design, that will not the case, ideal case, because whenever we take our experiments and all, it will be always data imbalance will be there. But the thing is that we have to encourage, or we'll try to make sure that a data imbalance should not be there. So equal that is self frequency make it easier to the what do you say, disentangle, like something like it's easier that effect of a row and column that we can, and then we can minimize the effect of the non-homogeneous population variation if they exist. So that's why it's very important to that data should be that balance instead of data imbalance will be coming. The chances of the error will inflate and all. So if we go with that mathematical formulation, so we'll see what is the purpose was there. Purpose of the two-way ANOVA. We'll see problem. Actually, I'm just trying to explain and explain so that if you're coming across any problem, so that you will able to catch it up like which test we should apply and all. So we have the purpose of two-way. We'll check with the evaluate the main effect of factor A, then main effect of factor B, then we'll check with the interaction. So till last class, what we were saying, we were not talking about anything about the interaction. So here we are talking about the interaction. But I think that we have seen already why I j k is equal to mu alpha I beta j plus alpha beta ij plus error. Is it? So it's a mu we call mean or we'll say overall mean. Alpha will say effect of factor A. Then beta we have effect of factor B. Alpha beta is actually interaction effect. And then it's a called error or residual that will follow normal. Is it? So this is the whole things will go like this. Okay, so in the similar cases that will be having the ANOVA testing. ANOVA table will going to make it out. So it will be the SSA. It's called source. Source will be the factor A. Then we'll be having SS. Then we'll be having degree of freedom. Then we'll have MS. Then we'll have F. Factor A, SSA will give you the formula also. It's let's say for the factor A minus 1. That's called degree of freedom. Then MS will be SS by degree of freedom. Factor B will be SSB, B minus 1. And then we'll be having the interaction. So it's called SSAB, A minus 1 into B minus 1. Then we'll be having the error. It's called SSE AB into N minus 1. Then we'll come to the total called SST. It's called how much? N minus 1. Is it? ABN minus 1. ABN minus 1. Then F will go with the all will be the MSE. And then if you take A, so MSA or MSB or MSAB. So this is the idea about that how it will go. So what is the formula actually? SST. We already all know that summation of Yij square minus grand total square by n. Is it? So this is the formula for what you can say SST. If you take the factor A, SSA 1 by Bn. B will be the SSA, like the B will go. Then summation of what you can say Ti into Gt square by n. SSB 1 by An Tj minus Gt square by n. That we have seen already that I'll solve the problem that will be easy to get it. SSAB will be the 1 by n and a summation of I, J till go A, B, T, I, J, both minus SSA minus SSB minus GT square by N. Okay. Then SSE will become SST minus SSA, SSB, SSAB. Okay. So this is the whole idea of what you can say solving the problem. So can we solve one problem? Is it? So we have fertilizer, two types of the fertilizer, and then we have the irrigation. Irrigation we have how much? Low, medium, high. Fertilizer A and B. So we are having 2 into 3. Is it? So first step, what will be there? To calculate the grand total. How will calculate? Summation of all 50, 52, 55, 54, 58, 57, so on till will go 59. So it will come somewhere how much? 659. How much n we have? 1, 2, 3, 4, 5, 6. So n will be become 12. 6 here, 6 here, 12. 8 is. So now we'll calculate the SST. Summation of yi jk square minus gt square by n. So summation of 50 square plus 52 square so on plus 59 square minus 65 square by 12. So we'll get some value. So we'll get some value. How much? It will comes 36455 minus 36179.08. It came how much? 275.92. So this is the SST we calculated. Is it? So now we'll go with the factor A. Factor A will be how we'll get going to calculate? Factor A, how will calculate? We'll calculate the FA will be summation of all factors. So 50 plus 52, 50, 50, 50, 50. So how much? 300, 257, 7, 11, 11, 8, 19, 3 success. So it became 326. So that number, how much we have? 6 here. 326. Then it became how much? 5, 5, 5, 5, 4, 20, 25, 310, 310, then it will come 333. Okay, 6 it came. Okay. So now how will calculate? SSA. How will calculate? 1 by Bn summation of Ti square minus Gt square by n. How will do it? Can you just tell how will do it? How much we have? 2. Number 3. 326 square plus 333 square minus 629 square by 12. I think it's clear, or any doubt is there? Any doubt is there, or it's clear?
Yes, sir.
So SSA will come like how much it will come? I'll see the numbers 36194.17 minus 36179.08. So it will be 15.09. So now we calculated the SSB. So now we'll go with the factor B. So what will be there? We are having B. We'll go with that. What you can say? 53, 54, 56, 55, 60, 59. Is it? Like it will come like this: 50, 53 or 54, 55. TL, TM, irrigation will be what we have? Low. Irrigation, like total of low. So what we have the low value? Low. 50 here, 52 here, 53, 54. I'll tell you like how it's coming. Don't get confused actually. Now we have checked with the FB we have checked. Now what we have? FA and FB we have checked it already. So that now what we have? Low, medium and high. So now we'll check with the TL. TL means low for the all cases. Low where we have 50 plus 52 plus 53 plus 54. So 200, 349, 347 to 9. So it became 209. It's clear. Then T medium, T head. It's a total. T medium will become 55, that is a 54. 5, 5, 10, 20. So 9 become 9, 6, 15 and 20. So it became 220. It's clear. T high 60, 59, 58, 57. Total will come 230. So now we'll able to calculate the what you can say SSB. Just tell like what I have done, like how much it came. 2 into 2, 209 square plus 220 square plus 230 square plus minus GT square 629 square by 12. I think hopefully it's clear. Is it?
Yes, sir.
So you will be able to calculate. So it will come 36 to 45.25 minus 36179.08. So that the answer will be there somewhere called 66.27. So now we have done with the which one? What do you say? Now we have so now we have to go with the sum of squares for interaction. Is it A for the case of low? What is that? A for the case of low 50, 50 plus 50, 52. How much came? Then we'll go with the A medium. What is the value? 55 plus 54, 109. A high. Okay. So it's A high, it's a 58 plus 57. How much the value we have? 115. B low will go. So earlier what we will check? Just to 1 minute, like internet went. I think now it's fine now. Hello? Is it audible? Hello?
Problem, sir. So I did not hear anything.
That now is fine now because that internet went and then came back.
Now it's okay. Now it's clear.
Okay, thank you. Okay, so we were there, B low and B high. Earlier we used to check with the FA, it will be the all only A. Okay, so now we're going with the mix it up. So now B low, how much will be there? B low is the 53, that is the 54, 107. Then we'll be having B medium. We'll be having a 56 plus 55, triple one. Then B high will be having 60 plus 59 will be the 119. Now can we go with the SSAB? Formula is the 1 by n Tij whole square minus SA SSB minus GTA square by n. So we'll be able to see how it will work out. 1 by 2 because the n we have 2 only because the either A or B factor, is it? Then summation of all 1 not 2 square, 1 not 9 square plus 115 square till 119 square minus SSA. How much is there? 15.09 that we calculated. 66.17 minus 629 by 12. So we'll get some value. Is it? We'll get some value. It will come for points. So now, what is the next step? To calculate the SSC. Is it? Will be
Ye-
SST minus SSA minus SSB minus SSAB. So we'll be able to calculate. Then what will be the degree of freedom? First one will be for the factor A. How much we have? Like we have the 2 and that will call 2 and that what will say 2 minus 1 because only we have A and B. So 2 minus 1 it become 1. What about the for the case of what was that irrigation we have 3, is it factor B call 3 minus 1 2, is it? Then we have the AB 2 minus 1 into 3 minus 1 it became 2. Then what about the error? AB into n minus 1. A 2 3 into n, how much we have? 2 minus 1. It became 1. No, 3 into 6. Then we'll be having AB n 3 into 2 into, so it become that my voice is audible, na? Can you please tell? Hello? Hello?
It's audible, but little more loud means it's good.
Okay, okay. Yeah. So then we'll be having like a total, it's called AB n minus 1. 2 into 3 into 2 minus 1, it become 11. So can we make the ANOVA table? I'll take one page. So now we can able to make the ANOVA table. First one will be the source. Then we'll be having the SS. Then we'll be having the degree freedom. Then we'll be having the MS. Then we'll go to F. Source with the factor A, factor B, then interaction, then error, then total. So Uh, so that we can calculate. We calculate already this one, 2, 2. Then we have AB into n minus 1, 2 into 3 into 2 minus 1. So 6. And this one we have 11. So I think it's clear now. Now we can go with the RS square also. RS square will be the SSA plus SSB, SSAB by SST. I think till here it's clear now, like how we have to calculate the interaction effect. So this is called two-way ANOVA, is it?
Yes, sir.
So we'll solve one more problem actually. The problem will tell like that we are having a consumer that the research compares three brands of the tires. What is that? X, Y, Z. So we have factor A in terms of the lives, three road surfaces. So this is called factor B. Or let's say this called factor B. This will say factor A. Is it? It's clear. So that we have two factor, but we have X, Y, G, and then asphalt, concrete, and gravel. It means we have the two factor, not two that's called two level, but three factor. Is it? Then in the each cases that we have four, the designs are there. So total number of observation will become 3, 3, 6, 3, 3 into 9 into 4. So it will become 36. Is it? So now we'll segregate the data. S fall then will become surface brand observation. Then we'll take cell total. Why we are taking cell total, that will tell you that we're going to use asphalt X. Number of observation we have 36, 39, 39, 38. If we add all these things, that will going to calculate in the cell interaction. So that total will come somewhere 152. Then asphalt in the case of brand Y. So it's a 42, 40, 39, 42. It says 163. Asphalt Z 32, 36, 35, 34. It came how much? 137. Then we have concrete X 38, 40, 40, 40. No, 38, 40, 41, 40. It came how much? 159. Then we have a concrete Y 42, 45. No, 42, 45. But we have a concrete Y 48, 47. So it came how much? Concrete Y 42, 48. How much it came? 444, 160. 164, 160. 5 to 7, 7, 8, 15, 15, 7, 22, 182. Is it? 7, 3, 10, 10, 3. So 137. Then we have gravel. X 34, 32, 34, 33, 34, 32, 34, 33, 133. Gravel Y 34, 34, 30, 31. It came 126. Gravel Z. It came how much? 35, 36, 35, 33, here it came 139. 139. So now we'll able to calculate the grand total. It will be summation of 36 plus 39 plus till here 33. It will come somewhere how much? I'll calculate. So it came 1310. What we have, n is equal to 36. Is it? So calculate the SST, summation of yijk square minus gt square by n. It will be summation of 36 plus 39 summation till 33 square minus 1310 square by 36. It will come some value. Okay. One, three. This problem I'll solve, and then that next problem I'll just explain. I think this calculation we should do in some sort of programming language like that the MATLAB spaces and all, because it's a very lengthy that problem we have. Is it? Then we'll be able to do the row total surface. So asphalt will be able to do 152 plus 163 plus 137 that we have done, because that's a row. It's a row total. Like it's a, it can go this one. So this one we have how much? 152. Second one, why we have 163. Third one we have 137. So here the same thing we have done. That value came 452. Then asphalt के बाद then we have concrete. Same way, 159, 163, 138, 460. Then we have the gravel. Similar way, 133, 126, 139, 398. Is it? So then we can do the column total. How will do it? X. X we can see. X, this. So this X, this X, this X. 152, then 159, then 133. 152, 159, 133. It's a triple four will come. Y similar way, 163 plus 126. It's a 452. Z 137 plus 138 plus 139. 404. So now we'll go with the SSA 1 by BN TI square minus GT square by N. How will go? How much we have? N is equal to 4. B, how much we have? 3. 3 into 4. Summation of 452 plus 460 square plus 378 square minus 13 square by N. Means 36. So now what about the SSB? 1 by A. A, how much we have? 3. It's a 3. How much number we have? 4. Summation of 444 plus 452 plus 414 minus 3 by 36 is there. So I think SSA, SSB is the that's the clear we can do it. Is it? Now we'll go with the sum of interaction. How we'll do it? SSAB 1 by N summation of Tij square minus SSA minus SSB minus GT square by N. How will do it? 1 by n. How much? 4. Then we take all the number. All the, this whatever we took calculated here, cell, all summation square will calculate. We'll take it here. So 152 plus 163 square plus so on 139 square minus 164.56 4.89 minus 1 3 square by 36. So now what we can able to calculate? SSE. SST minus SSA minus SSB into SSAB. Is it? And degree of freedom will be, for the case of road, 3 minus 1 2. Surface, 3 minus 1 2. What about interaction? It will be A minus 1, B minus 1. It will become 4. Is it? And what about error? AB into n minus 1. 3 into 3, 4 minus 1. It will become 27. What about total? AB n minus 1. 3 into 3 into 4 minus 1, 35. So from all this data, can we able to do the ANOVA table now? Is it?
Yes.
I think it's clear. So we'll go to the next problem. We have different set of problem is there. Now what we were having all the that the raw data is there. If similar way, if the that instead of raw data, if they have given the x bar or variance, so how will do it? How will approach the problem? Is it? How will do it? Any idea you have? Shall I do or I'll just explain it and then I'll go ahead. Is it? So from the all over the mean they have given, we'll calculate the grand mean. 1 by AB, it will go I is equal to 1 to A, like it's a B, C, D, and all is there. Na? So we'll go with the A, B, J, X, I, J. So it will be 37.6 plus 32.4 plus 17.6 by 6. It will come 26.3. So it means what this mean will calculate the grand mean x bar or x grand. Okay. So what will be the what we can say SST formula that we have here in the case of summation of I j k into x I j k minus x grand r square. The question will be there. How will calculate the what you can say like this full? So we'll able to do SST is equal to summation of I j n into x I j minus x grand square plus I j n minus 1 n minus 1 Sij whole square. So instead of we don't have this one na, we have in terms of what we can say what we can say that is the x bar s square. So now we can calculate whatever number of means are there. Xij means x1 x like x1 like x ah x bh x bc. So we can calculate this one minus x grand that we calculated plus summation of n minus 1 6 minus 1 into Sij square. Already Sij square they have given. So we'll calculate directly summation, we'll take it out. So we'll do it. How they have done? I'll just show it once. One I will show. It will be how much we have? Like the total we have 6 now. 37.6 minus 26.3 whole square. Is it? 32.4 minus 26.53 whole square. Summation till 17.6 minus 26.53 whole square. We'll take 1 or 2 page. So it was SST. How we calculated, like summation xij minus x grand whole square plus summation. This is summation actually. N minus 1 Sij whole square. So what we have? 6. What is the value we have? 37.6 minus uh, 26.53 whole square plus what we have here, 32.4. So that the similarity will go for this also, this also, this also till 7.6. So this is the one part. Then what we have? N minus 1. It will become 5 into what will be there? All the summation 2.8 plus 10.3. Is it?
Yes, sir.
2.8 plus 9.3 plus till 4.3. So total it will come SST. If we calculate, it will come somewhere 2115.05. So now how we calculate what you can say? Sum of factor of A. Factor A. Factor A, what is there? We have, we'll take this as a A. Ability will be the A. Teaching method will be the B. So XH, that mean, it will be the high case, mean will be there. 37.6, 32.4, 33.2 by 3. Is it? XH, that high, all 3 by 3. Will come 34.4. Similarly, we'll go X low, XL. So it will come 18.67. So now SSA will become what? Can anyone tell? 3N into 34.4 minus 26.53 whole square. Similar way, what we have done for the SST also. Then what we have? 18.67 minus 26.53 whole square. Yes, okay. So it will come somewhere 1850.65. So this is came for the factor A. Now we'll go with the factor B. Factor, what are the things we have? XA. We'll take XA here. 37.6 by plus 20 by 2. 28.8. Similar way, XB will get some value 25.4. XC will get 25.4. So that value will be there. SSB, how much we have? 2. 2 into N. N, how much we have? 5. Then 28.8 minus 26.53 whole square plus 25.4, 26.53 whole square plus 25.4 minus 26.53 whole square. So we'll get some value 77. So calculate the interaction now. SSAB will be SST, SSA, SSB minus SSE. That SSE that we have calculated here, na? Here, this part, SSE will call because it's a error, na? Is it?
Yes, sir.
Hmm. So now we'll able to calculate SST. How much we have? 21.505 minus 1850.65 minus 77. If we do that, came a 169.6. Total came 17.8. Okay. So then now we can go with the degree of freedom. Ability. What is there? Ability. How much we have? Two. Either with the high or low. So 2 minus 1, 1. Teaching method. 3 minus 1, 2. Then interaction. A minus 1, 2 into 1. It will become 2. Error. AB into n minus 1. How much we have? 3 into 2, 6 minus 1, 30. Total AB n minus 1. We can calculate the 2 into 3 into 6 minus 1, 35. So now we can do the annotative one. I think it's clear, na? Is it?
Yes, sir.
So shall I go ahead with the design of experiments, like factorial design?
Yes, sir.
So what do you mean? What do you mean by factorial design? Can anyone tell? Like, can you please tell factorial design? So in any of the experiment that involve a study effect of two or more effect, factors will be there. A or B or ABC will be there. So if it is two factors, so AB will be there. If A, B, C, so AB, BC, CA, ABC will be there. So in general, that factorial design, like it's the most efficient for this type of the experiments. Let's say we have the two or three, so we can do the blocking, or we can do the like setting up the things we can do. By a factorial design, we mean that in each complete trial or to replicate the experiment, all possible combination of the level of the factor are investigated, like A, B, A, B, A, B, C, A, B, B, C, C, A, A, B, C. Okay. Or if you go with the 4, so A, B, C, D, then it will come the A, B, B, C, C, D. Then it will come with the A, B, C, then A, C, D, then D, B, and all will come so that all possible factors should come into the picture. Okay. So that replicate all A-B treatment combination when factors are arranged in a factorial design, so they are often that called crossed. The factor effect of the factor is defined to be change in the response product changed by the level of the factor. Means once A will change, B will also change. B change, A also change. So it's called that the main effect because it's referred to the primary factor for the interest in the experiments. Like A alone will call main effect. It's actually that the factorial, like we discussed two-way ANOVA. So two-way ANOVA extension will go 2 by 2 experiments. So it's called two-way or the 2 by 2 experiments. And if you go with the 2 to the power 3, to the power 4 and all, it will be changed. It's called factorial only. So that individual will call the main effect. And if it is interaction, we'll say interaction effect will be there. So if you see, I'll take some page. Let's say we have some examples are there. If you consider, let's say we are going to consider some simple experiment. Okay. Simple experiment we consider. So we'll be having factor A, factor B. So we'll take this, let's say, low, high. So here we are going to tell minus. This will say plus. This also low. This also high. It's a minus. No, it's a plus. It's a minus. So it's a simple like 2 by 2. So this is the two factor actually within the design factor are at the tool level. Like this is the two factorial with two level. So that when we say the factor low or high, that can be denoted as denoted as minus and plus respectively. Okay, so that the main effect actually it's going to be like alone factor A itself. So it will be like this. Some values will be there x, y, z, and t will be there. Okay, so this value will be there. So how we are going to calculate what we can say that the main effect of A. How we'll calculate? Let's say this is the factor A. This is the factor B. How will calculate? It's a average difference between the high and low. How we calculate? So this is going to be y plus t. Y plus t by 2 minus x plus z by 2. So so that will call that the main effect of A. What about the main effect of B? Main effect of B, how it will be there? Just can you please tell me? It will be x plus y minus y plus no t plus z. Sorry, by 2. So this is called main effect of B. Okay, so but here that we are seeing like so that will be the that will call A and B. Then we can calculate the AB also. So we can see here if that the response for that going from the from low to high, it's a straight line, but it's not cutting it out. So that will say no interaction. That will show one example actually also. If it is going to cross at some point, it will call there is a interaction is there. So I'll take one example actually. This is called low. This is called high. Again low. It's a high. It's a minus. It's a plus. It's a minus. It's a plus. It's a factor A. Factor B. We'll take some value here. If this value is going to be 20, 40, and this become 30, 52. Okay. So what is the factor A? Main of factor A will be summation of like average difference between the high and low. 50 plus 40 by 2. How much came when that the 50 plus 40 by 2 minus 30 plus 20 by 2. It came 46 minus 25. It came 21. Is it? Similarly, for the B, it came 50 plus 32. Like 30 plus 50, 52. 30 plus 52 by 2 minus 40 plus 2 by 2. how much it came? 41 minus 30, it's 11. So it's alone. So we can see there is not much difference is there. It's a like going only, increasing only. There is not so there is a parallel difference is there. Parallelly they are increased, so they will not cut anywhere. If we'll take one example, sometime what will happen that will not having what we can say same pattern here. The pattern is like similar pattern that 20 to 30, 30 to 52, 20 to 50, that is the 40. So we have same patterns are there, but some experiment, let's say we have one examples are there. It's called low, it's called high, again low, it's a high. Okay, so if we take the value, this is 20, this is 50, this is 40, but here it's a 12. Is it? Here it's a 12. So means this will call factorial design with interaction. Okay. So in that case, at the low level of factor B means B minus the effect of A will be what? This is factor A. This is factor B. They're saying low level of factor B at this point. What will be the effect? So it's called 50. 50 minus 20. It became 30. Okay. Then at the high level of B, the effect of A will be, what will be there at high level? It's a 12 minus 40. What will be there? 28. Is it? Or either one more case. At the low level of, what you can say, A effect of B. What will be there? 40 minus 20. It become 20. At the high level of A, effect of B will become 12 minus 50. It came how much? 38. So if we plot this one, so it will come like this. Okay. So it means it's interacting. Some intersection will be there. I think the part of intersection is clear now.
Yeah, it's
So now we'll see what you can say that the mathematical part. So that will become similar way what we have took for the two-way ANOVA. Y is equal to beta naught plus beta 1 x1, beta naught 2 x2, beta 1. Like it was there for us mu plus alpha plus beta plus alpha beta plus error. But here we have to regression line will be there. So only thing it will change to the y is equal to beta naught plus beta 1 x1 beta 2 x2 plus beta 1 2 x1 x2 plus error will be there. So all our things are same. Only thing that we have fit the line. Is it? So if we go to the first example that we were having, uh, what was that example? 20, 40, 30, 52. 20, 40, 30, 52. And then we were able to calculate that all the value. So that estimate of beta 1 will be beta 1 and beta 2 are the half of value of corresponding effect. Okay, means like beta 1 will become For factor A, we have calculated 52 plus 40 92 minus 25. So it was there 21 by 2. It's a 10.5. Beta 2 was there. How much? We calculated beta 2 here. For B, it's calculated 11 here. So it will become the 11 by 2. So 10.5. Okay. Then for the beta naught, it will be the average of what you can say all four response. What was that? What was the four that all four response? All four response 30, 50, 20, 40 by 4. It's a 30 plus 52, 20 plus 40 by 4. We'll take one. So it will be like beta naught will come how much? 35.5. So now the question will be that what is the alpha beta? Or maybe beta 1 2. As there is no interaction, so it will be the 1. Okay. So like that AB will be 1. So beta 1 2 will be 1 by 2.5. What is the fit line? Beta naught plus beta 1 x1 beta 2 x2 plus beta 1 2 x1 x2 plus error. So 35.5 plus 10.5, or how much was the value actually? 10.5 x1 plus 5.5 x2 plus 5.1 x1 x2. So eventually this value is very low for the interaction. So we can omit it. So 40.5, 10.5 x1 plus 5.5 x2 plus 0.5 x1 x2 will go. Sorry. So this is the our fit line. Okay. So I think till here it's clear, na? Or any doubt is there? Can you please ask?
Here in this step, I didn't understand, sir. First, what you explained was okay,
Uh-huh.
but now here I am not able to grasp.
Okay. So the whole idea is to we have to fit the line, regression line.
Um,
So what we'll do like for the two factor and to that level that the equation will become that is the regression equation will become that like this. Okay. So now the so that the next idea is to calculate the that the beta naught, beta 1, beta 2 and beta 1 2. Is it?
yes.
So I'll take one page and I'll tell like what is exactly it is. Okay, so y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 1 x1 x2 plus error. So this is that's a linear regression line. Like it's called multilinear. Is it? So this is the that is the slope, or this one for the effect A factor A. This is for factor B. This is for interaction. To calculate the beta naught, let's say we have 2 by 2. Let's say this is the low, high, high, low, whatever the value was there, it was the value of 20, 40, 30, 52. So beta naught will be whatever the value, all summation of all 20 plus 40, 52 by 4. Let's say if it is x1, x2, x3, x4. So it will be x1 plus x2 by 3 or 4 will be there. Is it?
This, okay.
Then beta 1, actually beta 1 is actually for the factor A. Okay. So it's a half of factor A value. So what is the factor A? Actually, what we have factor A, average difference between the high and low. It means this is the high, this is the low. So their average in the, this is the factor A, this is the factor B. So 30 plus 50, 30 plus 50, or how much was there? The 50, 40 was there, and this was the 30. I think so. So 52 plus 40 minus 30 plus 20 by 2, it will be the 2. Okay, is it?
Sir.
So it came 21.2, it came 20.5. Similarly, we can calculate the beta 2. Beta 2, how you that calculate? 50 plus 30, 30 by 52 plus 30 by 2 minus 40 plus 20 by 2 by 2. It came 10 by 2, 5. Or it's 11 by 2. So now we are that we have calculated the beta not beta 1, beta 2. So if there is a, like discrepancy is not there, so that here this model is actually without the interaction. So in that case, AB will become 1. So what will be the case of beta 1, 2? It's a AB by 2, 1 by 2.5. So I think hopefully it's clear now.
Yes, sir. Now it's clear.
Yeah. And if there is interaction will be there, so some value will be given. AB value will be either will be able to calculate that the way we have calculated in the previous question, or the value will be given. So we can calculate the beta 1 by 2 will be AB by 2. Is it?
Yes, sir.
Like if it is value then AB.
Previous one.
Yeah, yeah. That is the previous one that we can do. Because here we have done from here, but in this case that AB will be given. If not given, so there is a way to calculate. We can calculate it. Otherwise, that the raw data will be given, that we can calculate the individual that call main factor of A, main factor of B, then that we are calculating that interaction. So if we take the half of that factor A, factor B, it that will come beta 1, beta 2. To calculate the beta naught, that the summation of that the whole data set. Then SSAB, no, that not that is SSAB will be able to calculate the effect of interaction by 2. That will comes the beta 1, 2. I think it's clear.
Yes, sir.
Okay, so now we'll go like what is the advantage advantage of the factorial, whatever the factor or the level we have, we are able to do with the each and every combination. Like we are not able to left it out anything. Let's say we are doing for the that the case of row column. Let's say I'm going with the, we have two and two. So we are doing for the A, and that is individual, B individual, then AB. Let's say we have the A, B, C. We'll go with the A, we'll go with the B, we'll go with the C. Or we'll go with the AB, then we'll go with the BC, then we'll go with the CA, then we'll do with the ABC. So it means all possible combination that we can. So error will be bit less as compared to the what we'll able to take. Is it?
Yes, sir.
So that is the advantage of the factorial. Because 2 factorial, it will be 2 into 1. 4, like 4 into 3 into 2. It will go similar way. So it's a, some sort of factorial phenol. So that we can see here. Seriously, that error will be there. Now we can see similar way what we have done for the two-way ANOVA, is it? A treatment, SSA, A minus B, B treatment, SSB, B minus 1. Interaction we have done A minus 1, B minus 1. Error we have done for this one. Total we have done for this one, is it? So it's nothing, it's a two-way ANOVA only.
Okay.
And similar way we have calculated for this also SSA, SSB, is it? That I told like how to calculate the SSA and SSB. When we have the SSA, it's a 1 by Bn summation of that the total of that in the case of A, the SSB will be A by An and summation of that B factor. Then total we have calculated also SS total like cell similar way. I think it's clear now. Or any doubt is there, please ask. Here, any doubt is there?
So in back factorial design also we have this ANOVA table.
Yeah, because it will come now because we are taking all possible cases. Let's say this is the case of two factorial design. If it come 2 by 3, A treatment, B treatment, C treatment, okay. Then we'll go with the AB, BC, CA, ABC. It's all come interaction. Then we'll go to the error. Then we'll go to total. Okay, so actually this will not will go into C in the actual calculation. That will be solving with the MATLAB or SPSS and all. So that 2 to the power 3 design we'll see in the next session. Okay,
Yes.
so similar way, it's actually like the same thing because whenever we are going to design any experiment, it's a two factorial design. So means design. So we have to check with the some testing. So two factor we have so that we can do through the two-way ANOVA only, na?
Yeah.
Yeah. So now we'll solve some problem. Is it? That shall we go? Some 7 to 8 problems are there. Whatever we have done.
Can do personally now, sir.
Sorry.
With the same we will do in personally.
Okay. So here, like this, I will just explain like how it done. Like it's a similar way. We have two fertilizer A and B. With this, will let's say factor A and low and high. It's a factor B. Is it? So now the thing will be you have to calculate for the factor A effect, factor B effect, then interaction, then SST, then we'll able to calculate the SSC, then we'll go ahead. So I think it will be okay. Is it?
Yeah, yes, sir.
Then one more. This is also a big problem. Actually, this actually that usually done by some SPSS software and all, or maybe with the uh, MATLAB coding and all. Because we'll be having how much 4, 4, 4. So 12 into 3, 36. And then we have to take for the SST, we have to take all summation 130 square plus 155 square. It's a very uh, lengthy calculation, is it? But the idea will be same. In the material that we have factor A and temperature, we have factor B. Then the whole idea is same, is it?
To
Hello?
have this problem solved, you could put in the slide.
Okay. I'll try to keep it.
Ah, okay, sir.
Okay, I think that we have this is there in the PPT itself. So cell total will do, that the row total will do, then column total will do, then we'll calculate with this formula. Is it? We'll go with the total square and then SS row, SS column, then cell, interaction, then error. Is it? This is the degree of freedom for the row,
Hmm.
then column, then interaction, then error, then total. So this is how done for the each cell.
Okay.
This I'll keep it in the PPT.
Okay, okay, sir.
Okay, so can you just tell what is the answer for this? What is the primary advantage of that the using of UV ANOVA, using that multiple one-way ANOVA?
B answer, sir.
Okay, yeah, it's correct only. So it's going to reduce the no. It's a conceptual advantage, but time will increase. Why? Because the degree of freedom will increase and the number of factor will increase. So means this is not the advantage actually. Then it's going to allow for the interaction. Yeah, correct. Reducing the number of assumptions required. No, both are taking same assumption. Is it? One way ANOVA and then two way ANOVA will take same assumptions. It's ensuring the independence of the group. It's a design part. ANOVA will not give. ANOVA will going to assume. ANOVA will not give like it's a independence and all. They are going to assume it and then they will do the analysis. Is it? So this is the thing. What was second question? Can you tell in a two way ANOVA? What is the null hypothesis for the interaction effect? Can you just tell? Are you here only? Or you left?
Here.
Okay. So that the idea of null hypothesis is what is that? There will be a no change. Is it? So they're asking for the interaction. So that factor have no significant main effect. No, they are asking about the interaction. So this will be not correct answer. If it is saying for factor or main effect, this is the correct answer. So this can't be correct option, is it? Then interaction between the factor is not significant. Yes, because it's a null hypothesis. It's a null hypothesis. Residual variance is zero. It's a assumption, not the hypothesis. There is no variance between the group. That we have to do the testing na. Then after we'll come to know that na, because the group will be the factor A and factor B. I think it's clear. So that the B is the correct answer, is it? B is the correct answer. So means interaction hypothesis will be same. What about third one? In a 2 by 2 factorial design, how many treatment combinations will be there? 2 by 2. It's a 4. If it is 2 by 3, it will be 8. 2 by 1, it will 2. 2 by 0, 1. 2 by 4, it's a 16. Is it? So that the idea is to factorial design. It's a P by K. It's a P will be the level. That the K will be the factor. So that option will be 4. It's correct.
Yeah, correct, sir.
So we can see here P by K. K is the number of factor. P is the label. 2 by P. So P is equal to 2 is a factor. K is the label. So it will be going to be a 4. Which of the following best describe the 2 to the power k design? I think now only I explained. It's a p by k. K is the factor and then p is the label. So 2 by k with the 2 label with the k factor. I think A is the correct option. Is it?
Yes.
This is how it works. Number of factor, number of label, same. In a factorial design, the main effect referred to, just tell me what is that? The effect of in factorial device, main effect will be the individual. Let's say we have a 2 to the power 2, like two factor A and B. So A will be the main factor, B will be the main factor, AB will be the interaction. So this can't be the answer. This can't be the answer. Variability will be between the exponent block. This is again can't be the answer. This is the correct option. Is it? It's correct or not?
Correct, sir.
So main effect, one factor will change at the one time itself, not the interactions. Not. We can see the some examples here. The same way, whatever I told you in the case of this one, high low. Similar way here done also. Then we have next question we have which of the following design allow for the estimation of both main effect and interaction effect for the two factor? Just tell me
That is correct, sir.
which one?
A answer, sir.
Yeah, A will allow for the main effect also and interaction also. What about the Latin square design? LSD, they will control the two factor. They will not give the interaction. No interaction. Because we were having CRD, RCBD, LSD, GLSD, here 0, here 1, here 2, here 3. Is it?
Yeah.
But no
Interaction.
interaction. So this can't be the option. This can't be the option. Here also one way ANOVA, it will not allow for the interaction. So
Interaction.
this can't be the again. We can see here. What is seventh one? What is the total number of degree of freedom for the error in two-way ANOVA with two factor, three level each, assuming no replication? Two factor,
Multiple levels. Four, sir.
four.
No.
How come? Three level each,
Three level assuming no replication.
A, B, n minus 1. Two-way ANOVA, two factor, three level each,
Factors.
and there is no replication. This question is actually incomplete. How? 3 into it's come 2. Let's say this complete as a 1. So this 2 will be the option. I think. Can we say like
Not
this?
so clear, sir.
Because let's say I'm telling the terminal or I'm saying about treatment one method and the drug one method. So 1 into 1. Then in each what we have 3 is there 30 30 30 for the all cases. So what will be there? In this case, this will become a 2. But that is not possible because the only one is coming now.
Uh,
So 2 is the answer actually. Okay. Like I'm just taking the ideal case. Okay. We'll go to the next two more questions will be there. What are the following assumptions for the two-way ANOVA? This is there? Yes. Is it?
yes.
Homogeneity will be there? Yes. Normality will be there? Yes. This is not the assumptions. This is their properties or they have to do it. Is it? This will come after the test,
Yeah.
not the assumption. Is it?
Awesome. Yeah, yes, sir.
So interaction must be always significant. This is not the assumption, it's a testable outcome, not the condition for the performance ANOVA. Is it? In two-way factor, which of the following are tested using the F ratio? F, how we are calculating?
A factor A.
We'll go with the MSE. Either it can go MSA, MSB, or MSAB, but it can't be MSE by MSS. Is it?
Yeah.
So first option is correct, second is correct, third correct. This can't be the answer. Is
Yes.
it?
Yeah, yes, sir.
So that 3 is the answer. We can see here similar way that we are doing now. Effect A, B, this. Now we have the last question. Which of the following are the characteristic of the factorial experiment? They allow testing for the interaction effect.
Interaction.
Yes. Is it?
Yes, sir.
They use fewer experimental runs before compared to the one at a time experiment. No.
No.
They are limited to only two factors. No, it can be more than two also.
More
Is
than.
it?
Yes.
They provide more information on the combined effect of the factor. Yes. Because they are giving the interaction. So we have this and this will be the correct answer. Is it?
Yeah, yes, sir.
So that's all. For the session, like it's clear now.
Yes, sir.
It's this part is actually bit of lengthy. This analysis or testing will be done with that you can try in the um, MATLAB and all. Okay. If you do with the hand calculation, it will take much more time. So I think now that you have the idea which test to use, how to use and all, so that you can write the code and then that you can do. Any doubt with that till today?
Okay, sir. If it is there next to last week, we'll ask.
Yeah. Okay. Okay. Thank you.
So the exam also will be in the multiple choice question only, sir.
Yeah. Hopefully, it will be the multiple choice question only because some small that thing will be asked now. I think the way they are asking in that assignment now,
Ah.
that will be similar way
Okay, okay, sir.
because I think there will be no much calculation will be there. I'll just check it and I'll tell you in the next class.
Ah, okay, sir. Okay, sir.
Okay. Thank you.
So thank you so much, sir.